I mean, some chicken wire, some glue, some newspaper, you could make anything, and you're going to make a model of planet Earth. So the shape is going to be easy. But we're going to make it as tall as the front of this lecture theatre. So it's going to start around about there, the door. The centre is here, where there is a yellow cross. And if you look on the ground just below you there, you'll see another yellow cross. That's the other end of it. So the centre is, thankfully, this is half the length. So this is the radius. Are you getting the idea? We're going to make just this giant ball of chicken wire, paper, glue, of this size. So what we can do is, once you've made that, pull out your blue and green paint. We'll paint on some continents, so I don't mess this up. If we say that, you know, the Greenwich Meridian, get a nod. It's a yes, good. That's where kind of the east and west divide is. So let's say that that's straight ahead. So that's here. So England, in case you're wondering, is 53 degrees north. So that you go 53 degrees up, which is about there. That's where England is. It's about a foot tall and about 10 centimeters wide. So remember, that's 1,000 kilometers long in real life. So this is a whoppingly great. Anyway, let's do another one. Australia, just to even things out, is 133 degrees east. Now, here's the question: which way is east? That way. Very good. Which way does the Earth turn if this is my giant Earth? Yeah. It's going around anti-clockwise, right? Work that one out for yourself later. It took me about 5 minutes. Sorry, what? 133 degrees east. It's about there, and 25 degrees south. Incidentally, this is a demonstration of how latitude and longitude work. So that's Australia. It's over here. It's about so big, about this high, very dry. Mount Everest is, he says, and looks back, it is 28 degrees north and 87 degrees. So it's over here and about 20 degrees. So it's about there. So what we're going to do now that you have an idea of how big this paper mache Earth is we're going to make a model of Mount Everest. We're going to need some salt. We'll start with a pinch of salt. Gather that together into a pile. And next we'll need nothing. That's it. That is on the. Are you getting? Yes. Good. It's actually, it really is going to take some skill to make this thing. The Earth is actually phenomenally smooth. That's the biggest bump on planet Earth. The tallest thing on all of Earth. Yeah? Incidentally, if you dropped one of your hairs onto the giant paper mache Earth, it would be as tall as Canary Wharf Tower. So are we starting to get an idea of the size of planet Earth here? If you wanted to make a model of yourself, that's going to be difficult. You'll need to start with a single human hair and a very sharp pair of scissors. And you're going to need to cut it lengthways into 100 pieces. I haven't prepared one earlier. Do it. Now, while we've got it here, we might as well, it's not strictly speaking astronomy, but we've got a giant paper mache Earth in the building. We might as well have a look inside. The Earth, as you may know, comes in bits. It's not just solid dirt all the way through. The inner core is at about 6,000 degrees. It's mostly metal. It's solidified, I think, nickel or 9 or something. It's about, hang on, where's the center? The center's, it's about that big. Yes? The outer core is liquid metal. at about 5,000 degrees, it's probably it's a shell around that's probably about that far again. The mantle is lava, basically. That's where it comes from when it comes up through volcanoes. That's slightly thicker than the mantle. It's about out here. And if you remember where the edge of this thing is, I'm getting pretty close to the edge. Solid ground, in large quotation marks, is the thickness of your finger. That is solid ground. You are literally floating on lava. The Earth, for the most part, is a colossal ball of molten metal and rock. And it's still cold outside. Incidentally, remember our Mount Everest here? That defines, that's how thick, humans can't live that high. There's not enough air up there. You can go up there for a short time, you've got to come back down, you just can't live up there. So that is the thickness of the atmosphere around Earth where humans can survive. So if you think, remember, our giant paper mache Earth sort of starts here and ends around sort of here, and you get less than a millimetre of breathable air. In fact, about 4 centimetres up, there's no air at all. So we really are in quite a cosy spot here. Where am I going next? The moon, incidentally, is roughly the same size as Australia. In fact, that I discovered. So it's about that big. It's 150 metres away. So what's that? Down the road, across the road, I think. In between, nothing. That's why they call it space. Now, what are we doing next? Now, we're going to go through this. Oops. Yes, let's go back to this video. Let's go back to the start. Let's recap how big the solar system is. We're going to now move off Earth. We finally reached a planet, so congratulations. This giant paper mache thing is a planet. Let's have a quick recap how big things are in the solar system. So that's our giant paper mache planet. Neptune is just going to be huge. You'll notice Uranus isn't on there. It's about the same size as Neptune. I'll stop it there just quickly. You'll notice all the innermost ones are the smallest. All the innermost planets, the planets closest to the sun, are all small, and these are all the big ones that are out wide. That's a pretty general trend in the solar system. The inner ones are sort of rocky, and the outer ones are called the gas giants for obvious reasons. Let's just introduce the sun into this picture. Right, that is the solar system. Now that gives you an idea of the size of things in the solar system, but not the distance between them. I warned you that we're going to have to go to drastic measures in this talk. We're about to do that. So we're going to stretch a piece of string across the length of this lecture theatre. Now we can all do this. We're a smart group. We're in Cambridge after all. Can we pass this directly that way to the young person in the blue? Give us a wave. Hi, you're gonna get this to the other end, so this is all on you. So can you guys pass this directly that way? Making sure that, yep. It's taking longer than I expected. That's all right. That's just more string quicker. Okay. Is it still attached to that end? Can we try and keep it fairly taut, as in tight? Yes. Part of this is actually an experiment. I wanted to know if you could do it.